So we'll be looking at data mining. All right. Now, so data mining basically deals with a set of activities, okay, that enable us to analyze large sums of data sets. All right. We are able to extract some very important information or knowledge from the data that we analyze, and then it facilitates in decision making. And you know that in business intelligence, we've already established that it is all about what? Decision making. And so from previous lessons, we've talked about data warehouse and stuff like that. Here we are now diving in a bit deeper in how we can explore the data, and the activities that enable us to explore the data, to analyze the data, and then we are therefore able to do what? To come out with some relevant knowledge, all right, or some meaningful information that can enable us to perform or make the right decisions. Okay. So as you see, say experience indicate that data mining study requires frequent interventions by analysts. Okay, meaning that the whole process, due to its cumbersomeness and complexity, and at the same time to you trying to actually look out for things that you want per the very context you are getting the using that very data, it cannot be fully automated. You see, you will definitely have to intervene at some point, maybe in terms of the data selection, in terms of the attributes you are interested in. All these things come to bear. So it is not a fully automated process, but then there is also what the human intervention, sorry, that is also part of it. You get it? So the term data mining basically refers to the overall process of what? That consists of data gathering, data analysis, development of inductive learning models, adoption of practical decisions, and consequent actions based on the knowledge acquired. It might even seem like we are defining business intelligence from the beginning, but here the focus goes on in the analysis of the data, the exploration of that very data. Okay, that's why we are calling data mining. You are mining the data to be able to explore, to be able to analyze the data, understand what the data is about, be able to identify the patterns that are embedded in that very data. For instance, you have a data set of about maybe a 1 million data set of people who utilize a particular network service, all right? Now, you recognize that some people seem to only utilize this service at particular peak hours of the day. So your ability to be able to go through this humongous data set and identify the patterns in itself is one aspect of what data mining is about. Okay, so the purpose of data mining is to draw some conclusions starting from the sample of what past observations. So you remember that we talked about what the data warehouse, whereby we say the data warehouse will house data that are historical by nature, right? And so these are past observations, past data set we've gathered, and we apply some models on it, we explore the data, we analyze the data, and we are able to make some inferences or generate some conclusions on the entire population or the data that we have gathered. Now we say that data mining activities can be split into two major parts, and that is the interpretation and then the prediction, all right? So the interpretation, the purpose of interpretation is to identify regular patterns in the data and to express them through some criteria that can easily be understood by experts. So for instance, we have a data set of all students in GIMPA. Then as you come through the data, you begin to see some patterns within the data. Okay, you recognize that students coming from a particular SHS, right, are performing better or are performing in a particular way compared to some other students. You could get another data set about maybe sales. So you go to the mall, you collect their data set, maybe about a 2-year span data set. And you can see the items that seem to be bought at a particular period of time as compared to some items. So there are criteria that we use, okay, but then at the point in time when it comes to the interpretation, we are trying to understand the data. And in understanding the data, we try to discover or come out with what, or see the patterns that are embedded in that data. And when we see that, then we can express, so more or less the knowledge we've acquired, we express it in some rules and criteria that can be understood by experts within that particular domain. So when we recognize that, oh, okay, we see that when people buy these items in June, we recognize that the next day, women, maybe if men buy these items, women also buy these items the next day. That can be some pattern that you are discovering. And so you can deduce some rule or some criteria out of it. And that criteria generated is situated within the context of that application domain you find yourself in. Okay. Then there is also the predictive or the prediction aspect of data mining. Now, the purpose of prediction is to anticipate the value that a random value would assume or variable would assume in future. So, for instance, you are thinking about the fact that having this data today that, okay, 10 people have bought 60 items from my shop today. Another 10 people have bought another set of items from your shop the next day. Does it mean that the third day, another set of 10 people are going to buy similar items? So how are we able to predict the future? How are we able to predict some events? And remember, we've already talked about stochastic events and stochastic processes. And you realize that in real life situation, things are randomized. But then, irrespective of the fact that they are randomized, applying some very good mathematical principles or formulas or statistical tools, we are able to estimate some predictions. So you can predict that it is going to rain. Take, for example, the meteorologist, right? What we observe about them is that they gather rain rain in beakers, in some instrument over a long period of time. And this data that they've collected, these days we have sophisticated meteorologists using satellite gathering images and all that. And this data that we accumulate, we are able to use it to make some predictions about the weather. That, okay, it is going to rain in the next maybe 3 days, or the weather will be cloudy tonight, or it might be very windy the next morning. You see? So as you see on the screen, for example, a mobile phone provider may develop a data mining analysis to estimate its customers and the probability of churning in favor of some competitor. Now, when we say churning, is the rate at which your customers might leave or not use a particular service. And this tends to happen quite a lot. I hope you get it. Now, so once again, two major things we deal with regards to data mining: interpretation, prediction. So with regards to the prediction, we are anticipating the future, a particular value. We are anticipating how something would behave in future. Then interpretation, we are trying to explore regular patterns embedded within that very data. These regular patterns, when we discover them, can even help us to also even predict sometimes, okay? It also helps us to also organize ourselves. For instance, if it if we recognize that there is a pattern between men buying shovels and baby pampers also getting finished. So we realize that the rate at which baby pampers are leaving the shop and shovels are leaving the shop seem to be quite comparative. Then we might be having a conclusion that maybe men come to the shop to buy shovels, but when they buy their hardware, because maybe it might be their wives who may have sent them, they also tend to also buy what? Baby pampers. Or it could also help us to understand the nature of our customers. Does it mean that people who buy shovels are people who naturally may be having babies or kids? You see it? Good. So the interpretation and then the prediction of the data are critical things that we keep an eye on. Now, having talked about it in depth, we recognize that there are quite a number of models and methods for data mining, okay? And a number of techniques have originated from computer science, the field of computer science, which involve classification trees, whereby we can talk about decision trees, association rules. And these days, sometimes you realize that all of them are being jumbled together and we call them machine learning models, okay? Now, so we also have statistics playing a very critical role in machine learning models. We have the Bayesian classifiers, we have regression, and in the regression, we have linear regression, we have logistic regression, multivariable or multivariate regressional analysis. And these statistical tools enable us to be able to predict or analyze our data. Okay, now, so we turn our attention to the applications of data mining, and we can say that one of the applications is relational marketing. Okay, think about buying stuff on Amazon, and then there are recommendation systems, or doing some form of cross-selling. You are buying a mobile phone, and then you also see that they are advertising that you should also buy a charger and then an earpiece in attachment to what you are buying. These are all relational stuff, but it is coming as a result of what? Of data mining. Discovering the patterns in your buying, among your buyers. You recognize that your buyers buy some kind of, once they buy maybe a particular smartphone, these buyers immediately buy, they search for the next item, which will be maybe a wireless earpiece or earbud, or a particular maybe Bluetooth device. And so because we've gathered current data and historical data about past purchases, what we recognize that then we build our algorithm that actually is able to what? Suggest the next item that we think that our user should buy, okay? There is also the aspect of fraud detection. Now, think about cards, our Visa cards, our MasterCards. How are corporate bodies who manage these, or financial houses or institutions, able to detect that this kind of purchase that is being done on this card actually is a fraudulent activity? I've had an experience whereby I was there, and then my bankers called me that there is some purchase that is being done on my card. Am I the one initiating it? And I actually knew where it was coming from because I had signed up with a particular service. But then you realize that it's as a result of their tracking your purchases, tracking your purchase behavior. So if you realize that your purchasing behavior, it's like maybe you don't buy anything above, let's say, $1,000, or you don't buy things from the websites that you buy your things from. You've never bought things from this very website before, okay? And all of a sudden, there is a huge deduction that is about to take place on your card due to these models that we are talking about, these predictive models. We are able to detect that, hey, this very transaction should not go through. There is a tendency that this very transaction might be a fraudulent transaction. Okay, good. Then there is also what? Risk evaluation, whereby we evaluate, let's say you are embarking on a particular project, for instance, and we may have to be able to evaluate the risk involved in that very project. Now, this is where some of these models would come to bear, whereby we can plot in some data and the models can actually evaluate whether the risk in taking that venture is high or it is low. Now, text mining is one area which I would say that in our world today, it is becoming more and more common. Using NLP, natural language processing techniques, Gmail is able to, or Google is able to read your email and suggest the right response to that very email. If you indicate that there is, if you are typing a message and then you type the word attach, and then you happen to click the submit or send button, Gmail or Google is able to let you know that you are using the word attach, but then there is no file that has been attached in your document. And so text mining these days are something that is going on. I mean, apart from that too, there is using the optical, I think it's the OCR, character recognition, optical character recognition, whereby we can choose to, let's say you have a notebook of maybe you've written a poem, but you wrote it, maybe your grandfather wrote the poem with ink, pen, and now you would like to maybe scan it and then let it copy, the machine should copy the text and maybe document as a soft copy. What happens is that using these OCR techniques, we are able to read, so that one goes with what? Computer vision, able to read the handwriting of your grandfather, and then is able to translate it into some form of what? Readable text, which then can be composed into the sentences that you are already seeing. And as I mentioned, I made mention of what the image recognition, which is also a very, I mean, these days it's also quite rampant. You think about the airports, and maybe we are looking for a terrorist. Now, this is a crowd, an airport normally is a crowded area, and the terrorist could be among them in any way. It could even be disguised. But then if we are able to feed our computer with enough data about the terrorist's face, the nose, everything, and we run that very model on our camera system, the camera system would be able to what? Detect who the terrorist is among the various faces that we can all see. Then there is also web mining. There is web mining, there is data scraping. So we gather data online, we are able to use it to make some form of what? Predictions. We can extend this conversation in terms of the advanced tools that we use in building the web now. Some what you see is what you get, or WYSIWYG tools have embedded in them AI, which is able to make suggestions on the kind of content that should even be placed on the web. All right. There is also even medical diagnosis. we being able to predict that if someone is having cancer stage 2 or stage 4, when will the person die? Or how rapidly is the cancerous cells, how are they spreading? Are you seeing it? We have audio audio mining. So your mobile devices, as we are talking, certain words that we are using are being mined. And these are also being pushed up onto a particular database to help in understanding what is being talked about, and so they can serve you with the right advertisement. Okay. Now, with that said, at least now we have a good idea about what data mining is, and the fact that it's a very important technology in our midst today that enables us to do a lot. It helps us to gain a lot of understanding about our world that we live in. Now, we turn our attention to representation of what the input data. Now, remember, we are dealing with data mining, and that means per its name, we are dealing with data. Now, so normally we deal with a lot of data sets, and the data sets would probably be a two-dimensional table, which we normally call a data set, all right? Now, so the rows in the data set correspond to what we call instances, observations, or examples, or records. So if you take a Microsoft Excel spreadsheet, you would recognize that the rows that you see are all what are instances or records. And then the columns, okay, represent the information available for each observation, okay, and are termed as what? The attributes or the variables or the characteristics or the features, all right? Let me just see if I can just demonstrate one for you to see using Microsoft Excel. Good. If you take a look at this diagram here, now I could just insert another row here. I could say this is an ID. This is what? A book. This is maybe page, number of pages. All right. Let me just delete this side. Let me just delete this side. Now, we can look at this and see that, okay, now, this very row that has been highlighted, right? This very row that has been highlighted, let me zoom in a little bit. Good. So this row, row 2, is a record, is what we are referring to as what? A record. A record, an instance, or an observation. I hope it's clear. Then, when we look at the columns like this, these columns that we are looking at, so the book title column, this is standing for what? An information within a particular record. And this information can be termed as what? An attribute. Okay, it could be a variable. Number of pages is a variable. Book title, a variable. I hope it makes sense to everyone. Good. So we come back to our work. So that is it for the data set. The whole combination of the rows and then the columns gives us what? The data set. All right. Okay, good. Now, so we have different types of data, and we will be talking about them shortly. We have, when it comes to the data, we have the categorical, and then we have the numerical. Now, with the categorical data, we are actually dealing with what? Finite of distinct values, okay? In most cases, limited to less than 100. Now, examples of categorical data could be, let's say, a city. It could be maybe, let's say, series of names, a name of a customer, And these ones, we can represent them. So as you can see, are the province of residence of an individual, which takes a value of series of names, which in turn may be represented by what? Integers. But then we might not be doing any calculations with them. Are you getting it? Then there is the numerical, whereby this one has got to do with what? The finite and infinite numbers or values. And for them, we can perform arithmetic on them. Okay, so for example, the amount of outgoing calls during a month for a generic customer represents a numerical variable. The amount of shoes that are bought at maybe a mall represent what? A numerical type of data. Look at the example below regarding two customers, A and B, making phone calls in a week of 27 Ghana cedis and 36 Ghana cedis respectively. It makes sense to claim that the difference between the amounts, so you can, because these are numerical data by nature, we can perform basic arithmetics like what? Like subtraction to know the difference between 36 and 27, giving us what? 9 cedis. You see it? And we can even say that, okay, therefore, that means that A has spent 3/4 of what? Of the amount spent by what? By B. Now, we can go in further. When it comes to data, we have counts. Now, the counts are also what? Categorical what? Attributes. And they are represented using what? So these attributes can be represented using the Boolean variables, which could be true or false, and we can count them. So we can make them what? 0 and 1. So for example, a bank's customers may or may not be holders of, so we have this Boolean value. Or we can think about gender. Either you are a male or you are a female, or maybe you are a transgender. You see, then there is what? The nominal. The nominal kind of attribute or attribute are categorical data without natural ordering. All right. If we take, for example, your names, okay. If I mention Pascal, I mention Caleb, I mention Kelly, I mention Beatrice, I mention Angela. If I mention all these names, there is no order to them. Okay, they are nominal attributes. Then there are also what? Ordinal attributes. And the word ordinal coming from what? Order. So there is an order to it. For example, if you take the level of education, we have what? Primary, JHS, SHS. We have what? Degree or HND. We have what? PhD, or we have master. So that I've mentioned them in a particular order. There is an order to it. If you take the days of the week, there is an order within the days of the week. You see it? So the nominal comes with the natural, without any natural ordering. The ordinal has some form of what? Ordering. And you don't need to make any calculations out, or you can't say, I'm subtracting Monday from Tuesday, or I'm subtracting a PhD from, or let's say a primary from PhD, and I'm supposed to get master's. No. The point is, I remember that these are categorical. Okay, and as we said, the categorical are not numbers that we are utilizing for making any arithmetic operation. They help us in knowing the nature of the data we are dealing with. Okay. Now, when it comes to the numerical data, we also have two types. We have what? The discrete and what? The continuous. Now, the discrete attributes are numerical attributes that assume a finite number of what? Countable infinity of values. So like if I ask you, how many shoes did you buy? You can tell me that you bought 4 shoes. If I say that, how many cars have you bought? You could say that, okay, you have 5 cars. If I ask you, how many dogs do you have at home? You can say you have 5 dogs at home. Now, when it comes to the continuous attributes of numerical data, they assume uncountable infinity of values. So with continuous attributes, our focus is more on what? Precision. For example, the weight of a baby. You see, you cannot say the weight of a baby is 1, because the weight of a baby would really be varying. It could be 1.6, 0.7, so 1.6789. You can take that same weight again and you are going to get 1.946. So normally we are dealing with some range of what? Of numbers. It's not finite as the way we will be dealing with what? Discrete figures or discrete numbers. I hope it makes sense. So the discrete numbers we are dealing with 1, 2, 15, 60, 75. Those are discrete, finite. The continuous ones, we are dealing with what? Values that actually move within a range. And so we are highly cautious of being quite precise about the value that we are putting out there. If you want to say the temperature of a room, if you say, you probably say 37.2 degrees Celsius, you can take the same temperature and get 37.257 degrees Celsius. So there is a range in what? In the values we are talking about. I hope it does make sense. Okay. So
yeah, makes sense.
Just doing a quick recap, we would recognize that this is what is going on. We have just looked at the fact that with regards to the data, we have what? Categorical and numerical. Now with the categorical data, we are saying that they assume some form of what? Distinct values. But these are normally in the form of, so sometimes people will say they are qualitative in a way, all right? And we've talked about the fact that we also have what? The numerical, which deals purely with the numbers. So that is what? Quantitative. Now, the categorical, we can talk about what? Counts as one of its attributes. We have nominal and we have what? Ordinal. Now, the counts are more or less the attributes that we can look at them as what? Boolean values, true or false, 1 or 0. But then we would not do any calculations with them. Categorical values are like that by nature. We don't necessarily do calculations with them. We have nominal. The nominal is also another attribute of a categorical data. They do not seem to have any ordering. So you mentioning the towns in Ghana, you can't say that, okay, because you mentioned a very low level, like a name that we have not heard before, it means that one town is better than the other town, unless you are going to use additional word metrics. Okay, why would you say another town is bigger than or better than another town? Well, I'm talking about in terms of population, or I'm talking about in terms of maybe social amenities. You see, now you are bringing in other qualifications such that at the end of the day, we can bring in what? Order. We can arrange them in a particular order. But then, naturally, nominal data do not have any natural ordering. Then we have what? The ordinal attributes. Ordinal attributes have order. There is a natural order to what? The ordinal attribute. And once again, it makes no sense to even calculate the differences or the ratios between the values. And we've explained that when it comes to the numerical side, then we have what? Discrete and what? Continuous. The discrete values, they assume finite numbers. So 1, 30, 77. So you bought 59 shoes. The continuous ones are the uncountable infinity value, 17.935, 16.12. These are what? Continuous values. Okay, so we turn our attention to what? The data mining process. Okay, with the data mining process, we start by having a definition, and then we would do data gathering. Then we'll create our data mart. So you would realize that the data gathering section, getting our data mart, the data mart more or less a subset of a data warehouse. Then we would apply we'll do some exploratory analysis on them, build our model, and then we can conduct either prediction or interpretation. So let's look at the stages one after the other. Now, definition of the objectives. Here, remember that the data mining that you are going to do, you are doing it in a particular domain, in a specific context. The data mining you might do in the health environment is totally different, and you will have total different objectives compared to someone performing the same data mining analysis in a bottling company. Okay, so data mining analysis are carried out in specific application domains and are intended to provide decision makers with useful knowledge. So as a consequence, intuition, competence, they are all required, because here we are now trying to define what we will be analyzing and why we are even going ahead with this data mining process in the first place. Okay, so if the problem at hand is not clearly defined, circumscribed, what will happen is that it will thwart whatever effort we are trying to achieve with our data mining activity. Because if you are not clear on why you want to embark upon it, and I would emphasize on this further, even in learning data mining, especially when we are dealing with the tools, let's say you want to use scikit-learn or some form of tool to be able to analyze some data, it is so critical that you define your objective. Why are you doing this? And be very clear about it, because the thing is that the tool you are using can be employed to do so many things. And if you are not clear on it, it means that you could waste time, or you could also waste resources. Okay, so once the definition has been defined, we could say that, okay, we want to be able to predict the population of students in a particular university in the next 5 years. That might be our objective. If that is our objective, now what do we do next? Now we need to gather data. I hope you understand. So we gather data, and the data gathering and integration is one of the tedious aspects of data mining, okay? Because here you need to get data from both the internal, the external, and also some data that maybe could be personalized data. It could be a lot of data that you would need. It could be the combination of the two that you will need. And then the integration of distinct data sources may be suggested by the need to enrich the data with descriptive dimensions. So when you'll be gathering data from maybe some geospatial system, you are gathering data from your work zone, and all of these things are supposed to probably be consolidated into one data set that you can be able to analyze. Therefore, you need to think of how you are going to do the integration, all right? Sorry. And once you're able to do you're able to gather the data and do the data integration, then we can move to the exploratory analysis. Now, that is the third phase of the data mining process. Here we perform, so it's more of like a preliminary analysis of the data. You are trying to have some sort of bird's eye view of how the data actually looks like. And also you want to do away with some inconsistencies or some errors that might be within the data. It could be, for example, that the date of birth that fall outside admissible ranges and negative sales charges are detected and corrected. It could be that the dates of birth, so let's say you've collected data from a social media app, And now this social media app, you are expecting that your data set should be about people who are within the age range of 19 to 25. But then in the data set, you recognize that there are some who are 18, some are 18.5, and they find themselves in your data set. So the exploratory stage is that stage that you would have to correct such data points, those inconsistent data points. Okay. So here it's more of like you will explore the data, understand the way the data looks like, and do some bits and pieces of data cleaning. Then there is also attribute selection. Now remember that our objective from the beginning is that we would like to predict the population of students in 5 years. Now, what would we need to be able to do this prediction about the data? So first of all, we need to know, okay, then that means we need the population of the students per year or per admission. You see, so that means our data set, we need population number, we need academic year, we need the semester, right? We need also even the courses that is attracting the students. So here, what we are doing is that we are doing what we call the attribute selection. And remember that when I showed you the diagram, the image of the Excel spreadsheet, the columns are the ones that are indicating what? The attribute. Let's just go there briefly and then come back here. So if you take if you take a brief look at this, I'll just clean everything that is in. We could say that, okay, we have academic year as one. We would say we need what? Students applied. We might need, so this is what? Potential student applied. We'll have what? Students admitted. Okay. We could have maybe programs. Good. So we could have 2020. We had maybe, let's say, 12,000 students applying, but then we admitted 3,000 students. The programs that they are all in, maybe we can say that maybe about, let's say, 7 programs, maybe, or let's say 16 programs. 2021, we had maybe 18,000 students applying. We admitted 4,000 students. Programs maybe still remain at 16. Now, what about 2022? We have probably, now we realize that we just get what? 16,000 here. And then we are getting what? Probably we admitted 5,000. So this presents an interesting data set that we may have to look at and be able to understand. So that based on, and you remember, these are the attributes: potential students applied, students admitted. Okay, these are attributes. And probably what are we trying to predict? We are trying to predict the number of students admitted, or are we trying to predict the number of students applied? You see, so we could have a huge set. Maybe this started from, we could say, let's say the school started 19. So maybe we could start from 2000 and maybe 15. And then we continue with what? 16. We continue with what? 17. It continues. And we could get a huge data set. And then we can be able to use it to predict. So in the prediction, we'll talk more about it as to how we actually do that. When we've talked about it briefly, but we'll get more deeper into it. All right, good. So let's go back to our show. So those are the attribute selection. We chose to select what? Student admitted. Someone will say, okay, let me look at student what? Potential student admitted. So what is going on critically here is that we are trying to discover, or we are trying to select the parameters that we are interested in per our objective. Okay, so for example, in most cases, it's helpful to introduce new attributes that reflect the trends. So you can also bring in your attributes. You think that, okay, the way things are, maybe I should collapse collapse two attributes and then form a new column. All right, and then that will become another attribute you are going to use or you are going to select. Okay. Now, so when we are done with the attribute selection, then what we do is that we embark on what? The model development and validation. So once we know, we are sure that the quality of the data set is high, okay? So we know that we've assembled and possibly enriched with new defined attribute. Now we can think of what? How we can develop our models for predicting the data that we want to predict. Okay, so that's what I said, we'll get more into it. So what happens most of the time is that we split, most of the time in data science, in machine learning, you realize that the data is split into two. Because remember, we are dealing with what? So let's quickly go online quickly, and then let's see if we can download a data set, all right? And we can see if, so Kaggle data set, if we can get some free huge data sets that we can just use it as an example. So Africa. So we have this. Okay, so we have a 3. So this is how the data actually looks like. Okay, good. Now let me download it. Oh. Okay, so I'm downloading the data set. Okay, so let me share with you my screen. Good. So there is a huge data set. How many rows do we have? We have about 1,060 rows, right? Not so humongous, but it's a lot of data. So if we have to do our prediction or whatever that we would like to do, what we normally do is that we split this whole data set into two. So we can say that since we have 1,000, we can split it to maybe, let's say, 2/3 versus 1/3. Now I'm going to say what I mean by 2/3. So if you calculate 2/3 of, so two, just a moment. So 2/3 of 1060, it gives us 706. So in this case, we are going to what? So let me show you what we'll do. This is a huge data set. So you are starting from here, 706. So let me just, so we'll take up to 707. Where is 707? So I could choose up to 707 here. Now, this whole data set you see here that you see the running, the marquee running around it, we could call it what? That becomes what we call our training data set. And the one that we did not select becomes what? Our test data. I hope it makes sense. Our training data set versus what? Our test data. So you will see that normally the training data set is huge and a test data set is small, so that we can be able to use that to build our model. Now that model is what we can say, okay, now we have a model and we can now test it on what? Future values. So it's like you have your question and you have your answer already. So using your question, which is your training data set, now you are trying to what? Use it to predict an answer that is already in your data set. And if you realize that it's able to predict it well, you are able to utilize the accuracy of the prediction is high, then that means that that domain or that document and that model is right. Let me try and see if I can use another. I normally have this here. So let me see if we can also use it to explain the point well. Okay, so hopefully, yeah, so we meet this guy too again, and this is data spell. So in this case, right, there is a data set here. This data set is about student hours. Now, this is about how many? It's about 29 rows. Now, we split the data into two. So this is what you are seeing over here, X string. Okay, let me see if I can expand increase my font size for you. So just a second. All right, so I think, yeah, editor, fonts, and then we have 16. All right, okay. So we can see that we have X string, X test. Forget about what you are seeing here. All that you need to see is that what we are trying to do is that we have splitted the data. So here, this X data that we saw here, if I am to, and I'm to run this, let's run this very form. Oh, I think we have, it's not because I've not, let me run everything. Everything will have to run before we can see the data set embedded in. But then all we are saying is that this X string takes the training set of the data. And you can see that we are saying that the test size is what? 1.5, meaning that all we are trying to say is that we've taken 4/5 of the data set as a training data and 1/5 of it as what? As a test data. I hope you understand. So that is it about what the reason why we split them into two. And once we see that, okay, the accuracy is that high, then we can be able to use it in future predictions. So it is upon that we now do what? Our predictions or our interpretations. So the model selected among those generated during the development phase should be implemented and used to achieve what the goals for which that is the objective. And we said we wanted to predict what the number of students that will be coming to our school in the next 5 years. Okay, and this would then be incorporated in our decision making. You see it? Good. So basically, that is what the whole concept of data mining is about. Actually, this is all that we are doing with regards to data mining. Now, we can, I'll break a little bit and see if there are any questions, and then we can proceed. All right. Please, any question? Hello, please, any question?
No, sir.
Nothing so far.
Right. I hope you all understand what we are doing.
Yes, sir. We are following, sir.
Okay.
We're following, sir.
All right. Now, so we turn our attention to what? Analysis and methodologies. All right. Now we've said that data mining, we are going to perform some form of analysis. Now, what are these analyses? What are the methodologies that are associated with them? Now we have two major, in fact, there are three, but the two major ones are supervised learning and unsupervised learning. Now, in a supervised learning, or sometimes we call them the direct learning, a target attribute. So in this case, it could be that we want to predict some form of data. So let me go through it and I will show you with the Excel what we mean by the target attribute. It that represents the class to which each record belongs to. Now, yes, so I think this example is in Vercelis, the book that I'm using to teach you guys. Now, so what happens is that you have your training data sets and you are trying to, or you have your data set and you are trying to predict a particular value. Now, for you to predict that very value or that targeted value, all you need is that you need to identify your explaining or explainable variables. Now, at this moment, it looks like I'll be throwing a lot of jargon. So let me just quickly go to the Excel sheet and we can. Now, we have, so I'm going to zoom in a little bit. All right, good. So let me highlight here. Good. So we have, good. So let's say we want to predict banking crisis. Banking crisis. Now, this is what supervised learning is about. In this context, in terms of prediction. Now, we would have to identify the variables we think can have an effect on the targeted attribute. In this case, the targeted attribute being what? The banking crisis. So it could be that we are looking at inflation. So does it mean that countries, so this is Africa, so we can see we have Angola, Central Africa, Ivory Coast, we have Egypt, we have, I don't know, do we have Ghana? I think, so we have Kenya, Mauritius, and stuff like that. Now, we all know that there was a time whereby several countries had some banking crisis and some banks folded up. So we would like to predict which bank is like a